Hello everyone, my name is Titus and today again we'll continue with our trigonometry chapter and we'll start with the question number 34 from exercise 21a. Okay, so let's start. So question number 34 is sin theta minus 2 sin cube theta. Sin theta minus 2 sin cube theta divided by 2 cos cube theta, 2 cos cube theta minus cos theta is equal to tan theta. So from the numerator we can pull out the sin theta and from the denominator we can pull out the cos theta. So now we can write sin theta, will take it out common and we'll write here 1 minus 2 sin square theta divided by, here also we can pull out the cos theta common and we can write 2 cos square theta minus 1. So we'll simplify this. First of all, sin theta by cos theta is tan theta and into 1 minus 2 sin square theta, we will keep it as it is, 2 sin square theta divided by, what we will do now here, 2 cos square theta I write in form of sin square theta. So 2 in place of cos square theta I write 1 minus sin square theta and then we have minus 1. So it will be tan theta into 1 minus 2 sin square theta divided by 2 minus 2 sin square theta minus 1. So it will be tan theta into 1 minus 2 sin square theta divided by, so here we have 2 minus 1 is 1 minus 2 sin square theta. So these two will cancel out and our result is tan theta. So we proved LHS is equal to RHS. Now we will come to question number 35. So question 25. We have sin A by 1 plus cos A. Sin A by 1 plus cos A is equal to cosec A minus cot A is equal to cosec A minus cot A. Okay. So sin A by 1 plus cos A is equal to cosec A minus cot A. So let's see how to do. We have 1 plus cos A in the denominator. So what we will do, sin A and then on the denominator we write 1 plus cos A will multiply 1 minus cos A on the denominator and 1 minus cos A on the numerator. So now when we solve it, we have sin A into 1 minus cos A divided by 1 plus cos A to 1 minus cos A, that will be 1 minus cos square A. So that will be sin A into 1 minus cos A, and we know that 1 minus cos square A is sin square A. Sin square A. So from this we can cancel out the sin A from the numerator and denominator, and then we have 1 minus cos A by sin A, and now we can write it as 1 by sin A minus cos A by sin A. So that is 1 by sin A is cosec A and cos A by sin A is cot A. So now you can check, this is the same. So now we have proved LHS is equal to RHS. So now we come to question number 36. So question 36. So question 36 is cos A by 1 minus sin A. Cos A by 1 minus sin A is equal to sec A plus tan A is equal to sec A plus tan A. So what we will do? We have cos A by 1 minus sin A. So we will multiply 1 plus sin A on the denominator and 1 plus sin A on the numerator. So numerator part we leave it as it is. So it is cos A into 1 plus sin A, and on the denominator, since we have 1 minus sin A into 1 plus sin A, we will multiply and we will get 1 minus sin square A. That is cos A into 1 plus sin A, and in the denominator 1 minus sin square A, I can write it as cos square A. Cos square A. So from here again we get product of cos A from the numerator and denominator, and now we have 1 plus sin A divided by cos A, that is 1 by cos A plus sin A by cos A. Okay, so this will simplify further. 1 by cos A is sec A plus tan A, and hence we have proved LHS is equal to RHS. Now we come to question number 37. Question 37 we have sin A tan A, sin A tan A by 1 minus cos A, 1 minus cos A is equal to 1 plus sec A, 1 plus sec A. Okay. So now we have sin A, tan A we can write sin A by cos A, and on the denominator this part we write 1 minus cos A. Okay. So sin A into sin A is sin square A, sin square A by 1 minus cos A into cos A. Sin square A I can write 1 minus cos square A, 1 minus cos square A divided by 1 minus cos A into cos A. 1 minus cos square A we can split, and we can write now 1 minus cos A into 1 plus cos A, because it is on the form A square minus B square. So divided by 1 minus cos A into cos A. So these two we can cancel out, and we have 1 plus cos A by cos A. So 1 plus cos A by cos A, that is equal to 1 by cos A plus cos A by cos A. So 1 by cos A is sec A plus cos A by cos A is 1. So now we have proved again LHS is equal to RHS. So So now we will come to question number 38. So question 38 is 1 plus cot A minus cos A. 1 plus cot A minus cosec A and 1 plus tan A plus sec A. 1 plus tan A plus sec A is equal to, we have to prove it as 2. So simplify and we will write 1 plus cot A, 1 plus cot A, I can write cos A by sin A minus 1 by sin A, and here again you can write 1 plus sin A by cos A plus 1 by cos A. So here we can take LCM as sin A, and now here we have sin A plus cos A minus 1, and here we have cos A on the denominator, and we have, since here we have no cos's, we have cos A plus sin A plus 1. So what we will do now? So these two and these two will be taken as one term, and now we can write this of the form. Okay. So on the numerator side we can write sin A plus cos A minus 1 into cos A. Sorry, we can rearrange it. We can write sin A plus cos A plus 1 divided by sin A into cos A. Okay. So here this is the form A minus B into A plus B. So I can write it as sin A plus cos A whole square minus 1 divided by sin A cos A. Okay. So we will rub this one and we will try to solve it here. So sin A plus cos A whole square, we can expand it. We can write it as sin square A plus cos square A plus 2 sin A cos A plus 2 sin A cos A minus 1 divided by sin A cos A. We know sin square A plus cos square A is equal to 1. So we can write 1 plus 2 cos A sin A minus 1 divided by sin A cos A. We will cut off this plus 1 minus 1. And then we have 2 sin A cos A divided by sin A cos A. We can cut off the common from the numerator and the denominator, and our answer is 2. So now again we prove LHS is equal to RHS. Now we come to question number 39. question 39 is 1 plus sine A. So 1 plus sine A by 1 minus sine A whole under root is equal to sec A plus n A is equal to sec A plus n A. So here on the top we have plus and we don't have anything on the denominator. So this denominator part we have to remove. So how to remove it? So first what we will write 1 plus sine A by 1 minus sine A under root. Now inside the root we will multiply 1 plus sine A on the denominator and 1 plus sine A on the numerator. Because you know the this by this is same as 1. So by multiplying 1 on the top and the bottom we are not multiplying actually anything. Okay. So now we have here 1 plus sine A whole square divided by 1 minus sine A to 1 plus sine A, that is 1 minus sine square A and root. So here we have 1 plus sine A whole square by, you know that 1 minus sine square A is cos square A. Now we can remove the square root because we have the two squares. So now we can remove the square and square root and we can write 1 plus sine A by cos A. That is 1 by cos A plus sine A by cos A. 1 by cos A plus sine A by cos A. So that is 1 by cos A is sec A and sine A by cos A is tan A. So we proved LHS is equal to RHS. Now we come to question number 40. So question number 40 is 1 minus cos A by 1 minus cos A by 1 plus cos A under root is equal to cosec A minus cot A is equal to cosec A minus cot A. So now here we have minus on the numerator. So we have again have to remove the denominator. So what we'll do? So 1 minus cos A by 1 plus cos A under root, and inside this square root we'll multiply 1 minus cos in the numerator, 1 minus cos A on the numerator and 1 minus cos A on the denominator. Okay. So now we have 1 minus cos A whole square divided by 1 plus cos A to 1 minus cos A, that is 1 minus cos square A and root. So that is 1 minus cos A whole square divided by 1 minus cos square A is sin square A. Sin square A hits the root. So now we can remove the square root and we can write it as 1 minus cos A by sin A. So that is 1 by sin A minus cos A by sin. That is equal to, so 1 by sin A is cosec A